Hi guys, in this video we're going to have a look at how to rationalize surds, and we'll start off really basic. So for example, you have root 2, we need to rationalize it and therefore remove the square root, and the only way we can do that is multiplying it by itself. So root 2 times root 2 is root 4, but we don't normally go to this stage, we just say it's 2. You can see that it just stays the same. If we have, let's change it to 4 root 3's. The easiest way of doing it is 4 is just telling us how many of these surds we have. So the only bit we actually need to multiply is by the surd itself. So it'd be 4, and if you like 4 root 9's, but try and not do this, it just slows you down. Root 3 times root 3 is just 3. So you've got 4 3's, again here, 4 3's, which is 12. Now the difficulty comes when there is two surds together. So what I mean is, or two terms, one can be a surd like this. If I put it in brackets, it just emphasizes that there's two. Now to rationalize this, if you multiply it by root 2, it doesn't work. I'll show you why. Because that is root 4. That's why I laughed, because I thought it would actually work. But that is root 4, or just 2. But then you'd have another root 2, so you still have the surd there. Let's get rid of those. Okay, so what you actually have to do is multiply it, and that bit. Multiply by what we call a conjugate. Kind of like you do in languages, you conjugate verbs. We're going to conjugate a surd, and it means pretty much exactly the same thing, but a minus. It kind of plays on the difference between two squares, because when we expand this, we get 2, then we'd have a minus root 2 and a positive root 2, which therefore, oh sorry, that's a 2, which therefore would cancel each other out, and minus 1, which would give us 1. So if we multiply by its conjugate, we get 1. Let's have a look at some more. So if we have root 3 plus root 5, for example, the only way we're going to rationalize that is times it by the same. We call it the conjugate. It's the same, but the signs, the operation is swapped in the middle. So if we had this one, we would multiply this one by 4 plus root 2. Now, let's have a look at a question. Here's one here. So we've got root 5 plus root 2. Sorry, that's not a question. That's an answer. I do apologise. So let's have a look at this one. Nice simple one. So it's 1 over 3 plus root 2. So here's the surd. It's attached to this, so we can't just multiply by this. We need to multiply using the conjugate. So we're going to times top and bottom, and the reason we do top and bottom is because it is a fraction. So whatever we do to the top, we must do to the bottom, otherwise we're actually changing that fraction. So we're timesing it by 3 minus root 2. Which would give us, because it's a 1, it's very easy, because it's just going to be this numerator on its own. So it would be 3 minus root 2. And if we were to expand these, I'll just do it down here to make it a bit easier. So we'd have 9 for the first two terms, minus 3 root 2's plus, oh, that's disgusting. Minus 3 root 2's plus 3 root 2's, which would therefore cancel each other out, and then this final root 2 times root 2 is just 2, so it's negative because 1 is a positive and 1 is a negative. And therefore we get 7. So we have rationalized the denominator, and that is the answer we are expecting. I was right, this is actually a question. It's just a funny looking one. I just didn't see this bit. So, this was the question. So, to actually to rationalize this denominator, we're going to have to multiply by its conjugate. So it times in top and bottom by root 5 plus root 2. And this is a good one actually, because it will show you that if we multiply by exactly the same thing, it will not be rationalized. So we've got two things to do here. So take our time. So root 5 plus root 2 multiplied by root 5 plus root 2. So here I'm going to have 5. The first term to the last term, that's going to be root 5 times root 2, which is root 10. We're going to have another one of those. You can see they won't cancel. And that is 2. Leaving me with 7 plus 2 root 10s. You can see there that the surd is still apparent. It's not been rationalized. Hence why we need the conjugate. So it's 7 plus 2 root 10s. 10. And so here we have root 5 minus root 2. And we're going to multiply that by its conjugate. So I'll do this one a bit quicker. So that's 5. That and that's going to cancel each other out. That'll be minus 2, which is 3. And there you have it. So the denominator has been rationalized.